Have you ever found yourself swimming in search results, maybe sifting through just endless articles trying to get smart on a new topic?
Oh, yeah?
Or maybe you've been hit with online recommendations that just completely miss the mark.
Happens all the time.
It's a common experience, right?
Yeah,
We have more information than ever, but finding those truly relevant, timely insights, well, it can feel elusive.
definitely.
Well, today we're taking a deep dive into the fascinating world where large language models, or LLMs, are really fundamentally reshaping how recommendation systems and search actually work.
It's a huge shift.
And this isn't just about making your Netflix suggestions a little bit better, though I mean it certainly does that.
For sure.
This is about a really profound shift in how technology understands what you want and, how it delivers it.
Exactly. Understanding intent.
So we've got a fantastic set of sources to guide us today. Insights from leading companies, think Amazon, Kuaishou, Indeed, Spotify, Netflix, Etsy.
Some big players.
Right. Our mission is basically to distill the most important nuggets, those aha moments, and the surprising facts that will hopefully leave you feeling truly well-informed about the future of how tech anticipates and serves your needs.
Yeah, cutting through the noise.
Now, it's worth noting that language modeling techniques, well, they aren't entirely new in recommendations.
No, not at all.
We saw early item embeddings pop up around, 2013? Learning from how users interacted with stuff?
Right, based on sequences.
Then came gated recurrent units, GRUs, which were pretty good for predicting the next item in like a short sequence of user activity.
Yeah, for session-based stuff.
And of course, then transformers and attention models came along and just revolutionized things, right? Letting systems process much longer user sequences.
Oh, absolutely. Hundreds, even thousands of item IDs capturing, like, a whole user history.
But what's happening now, it feels truly transformative. We're going to unpack 3 core ideas that are really powering this revolution: semantic IDs, data augmentation using LLMs, and the rise of unified models.
Sounds good.
Okay, let's dig in.
Let's do it.
So let's start with a significant problem. A lot of traditional recommendation systems grapple with these hash-based item IDs.
Right, the old way.
Imagine an item's ID is just like a random string of numbers. It encodes absolutely zero information about the item's content itself.
Nothing meaningful, yeah.
And this leads straight to the infamous cold start problem for new items, right? The system has no clue what it is, so it can't recommend it.
Yeah, place it at all.
And it also causes sparsity for the less popular tail items, which have very few interactions.
Yeah.
Often this just results in a popularity bias where only the stuff that's already popular ever gets recommended.
Exactly. It's a cycle.
Yeah.
And the striking thing here is how semantic IDs directly tackle those challenges. These IDs do encode content, and quite powerfully, they can even handle multimodal content.
Multimodal, meaning?
Meaning information from images, video, text, audio, all combined.
Wow, okay.
And this immediately helps with the cold start and sparsity problems, because the system understands an item's inherent characteristics, even if no one's interacted with it yet.
That makes sense. A compelling real-world example of this comes from Kuaishou, right? A massive short video platform in China, kind of like TikTok.
Huge scale, yeah.
Their challenge was just immense. Users upload hundreds of millions of new short videos every single day. How do you possibly learn from that volume of new, diverse content and make it discoverable?
It's mind-boggling. So Kuaishou approached this using what they called trainable multimodal semantic IDs. They used a pretty standard 2-tower network.
Okay, the 2-tower model.
Right, where one tower processes the item, the other processes the user or query. They combine static content embeddings with dynamic user behavior.
And for the content itself.
They use specialized models: ResNet for the visual stuff, BERT for video descriptions, and VG-GISH for audio. Pretty standard, powerful encoders.
But what I find really ingenious about their method is how they handled the sheer complexity of those encoders. Instead of trying to backpropagate through these incredibly complex models to learn the IDs, which sounds computationally insane.
Right. It would be. Instead, they took all these content embeddings, the outputs, from ResNet, BERT, VG-GISH, and just concatenated them together.
Just stuck them end to end.
Basically, yeah. Then they used k-means clustering to learn a much, much smaller set of cluster IDs. So think like from 100 million videos, maybe distill it down to just 1,000 cluster IDs.
And okay, compressing the information.
Yeah, exactly. And these cluster IDs were then mapped to their own embedding table. The brilliance really was that as the whole model trained, The encoder implicitly learned to map that rich, high-dimensional content space through these compact cluster IDs directly to the behavioral space. It learned how users interact with that type of content.
Ah, that's clever. And the results, were they noticeable?
Yeah, they were really notable. These semantic IDs didn't just outperform the regular hash-based IDs on metrics like clicks and likes, which you'd kind of hope for,
Sure.
but crucially, they significantly increased cold start coverage, meaning more new videos were actually getting shared and discovered by 3.6%.
That's pretty significant at their scale.
It really is. And they also boosted cold start velocity, which is how quickly new videos hit a certain view threshold.
Ah, so getting traction faster.
Exactly. So what this really means for you as a user is that recommendations can now genuinely understand the content. They can suggest something not just because other people clicked it, but because its inherent features align with your tastes.
And they could even explain why.
Potentially, yes. Generate human-readable explanations. That's a really significant leap forward in relevance, I think.
Definitely. Okay, moving from understanding content to actually generating it, let's talk about that perennial challenge for machine learning, getting good quality data at scale.
Ah, yes, the data bottleneck.
It's the lifeblood, right? Especially for search and recommendation systems. But getting rich metadata, query expansions, synonyms, spell checking, traditionally that's super costly and high effort. It relies heavily on painstaking human annotations.
Oh, absolutely. Manual labeling is slow and expensive, and this is where LLMs are proving to be a pivotal force. They're just outstanding at generating synthetic data and labels. They can provide richer, high-quality data at a, significantly lower cost and effort than human annotation ever could.
It's a game changer for data acquisition, a fantastic real-world example of this, and it sounds like quite a journey of trial and error comes from Indeed.
Right, the job site.
I mean, I'm sure many of us have felt that frustration of irrelevant recommendations, whether it's jobs or products or whatever. I know I have, getting emails that just make me want to hit unsubscribe immediately.
We've all been there. Indeed faced a really critical problem. They were sending out job recommendations via email that were just a bad fit for the user. Simple as that.
And that's bad for business.
Right,
Yeah.
extremely. It led to a poor user experience, obviously. But critically, users would unsubscribe from these emails. And that's an action that's almost irreversible, right? You lose that communication channel.
Very hard to get back.
Exactly. Now, they had some explicit negative feedback, people maybe flagging jobs,
Yeah.
but it was really sparse.
Not enough data points.
Right. And implicit feedback like a user just not acting on a recommendation, well, that's imprecise. You know why they didn't click? Were they busy? Did they not see it? Or was the job truly irrelevant?
Too much ambiguity.
So their journey, it started with human experts, manually labeling job recommendation user pairs based on resumes and activity history. The classic approach.
Time-consuming, I bet.
Very. Then they tried prompting open LLMs, things like Mistral and Llama 2,
Yeah.
but the performance was poor. The output was generic. The models struggled to pay attention to the important details in resumes or job descriptions.
Okay, so open models didn't quite cut it initially.
Not out of the box. Next, they prompted GPT-4. And that worked quite well, actually, around 90% precision and recall, which is good.
But there's always a but.
But it was way too costly and slow. Took about 32 seconds per recommendation to evaluate. You just can't do that at scale for email campaigns.
No way. Okay, so what next?
They tried GPT 3.5, hoping for cheaper and faster,
Hmm.
but its precision was low. Only 63% of the recommendations it flagged as bad were actually bad.
Ouch. That means they were throwing out good recommendations.
Exactly. They were discarding 37% of potentially good recommendations.
Wow.
That was a guardrail failure for them. Totally unacceptable.
Right, can't do that.
So then they fine-tuned GPT 3.5 on their own data. And this got them much closer to their desired precision, around 0.83. And it was at like a quarter of GPT-4's cost and latency.
Better, but still slow.
Still too slow for online filtering, yeah. Took about 6.7 seconds.
Yeah.
Still not feasible for real-time decisions.
So the breakthrough must have been something else.
The breakthrough came when they distilled a lightweight classifier. Basically, they trained a much smaller, faster model using the high-quality labels generated by that fine-tuned GPT 3.5.
Ah, using the big model to teach a smaller, faster one.
Precisely. This classifier achieved strong performance and 0.86 AU ROC score, which is a good indicator of distinguishing good from bad.
Right, that metric tells you how well it separates them.
Exactly. And crucially, it was fast enough for real-time filtering, under 200 milliseconds.
Now we're talking. And the outcome for Indeed.
The outcome was pretty striking. They reduced the number of bad recommendations sent out by 20%.
Okay, that's solid.
But here's the really interesting part, kind of counterintuitive. Application rates actually increased by 4%.
Increased by sending fewer recommendations.
Oh, fewer bad ones. And unsubscribe rates decreased by 5%.
Wow, that's a huge win. So sending less junk actually made people engage more and stick around longer.
Absolutely. It really underscores that point.
For a company maybe struggling with users leaving because of irrelevant stuff, what do you think is the core lesson here? What should other companies take away?
Well, for me, it highlights that in recommendations, quantity just isn't everything. Focused quality makes a significant measurable difference.
Quality over quantity.
Definitely. The real insight is how a small reduction in bad recommendations can create this disproportionately large positive ripple effect on user engagement and retention. It's a clear win for focusing on quality, not just volume.
Makes perfect sense. We see a similar story, kind of LLM-powered augmentation, but with a different focus over at Spotify.
Right, with their content expansion.
Yeah, Spotify, we all know them for songs, artists, but they wanted to expand into podcasts and audiobooks. Big strategic move.
A whole new area for them.
The problem, though, a massive cold start challenge for these new categories. How do you help users discover this new stuff without resorting to, like, obtrusive banners or annoying ads?
Yeah, how do you surface it naturally?
Their solution was a clever query recommendation system. They started by generating initial queries just from their existing data, things like catalog titles, playlist titles, search logs.
Using what they already had.
Right, even taking an artist name and just adding the word cover to it. That was their baseline. Then, and this is key, they used LLMs to augment these baseline queries with natural language queries.
Making them sound more human, more like how people actually search.
Exactly. The idea here, which I think is smart, is you don't necessarily need the LLM for everything right at the start. Use it to enrich what you already have.
Leverage its strengths strategically.
So these new augmented natural language queries were then ranked alongside the immediate search results.
Okay, so integrated into the existing search flow.
Yeah, and the user experience innovation here is subtle, but I think really effective. When you search on Spotify now, you still get your immediate results, but right at the top, you might see these contextually relevant query recommendations.
Like suggestions for related searches.
Exactly. And this approach just seamlessly informs you about new categories like audiobooks or podcasts related to your search without needing a big, flashy banner.
And much less intrusive.
And the outcome, a significant plus 9% increase in what they call exploratory queries.
So people were clicking those suggestions.
Yeah. Essentially, about 1/10 of Spotify's users were now exploring their new audio products daily, just through these subtle query prompts. And that drove really rapid category growth for them.
That's impressive growth, driven by discovery.
Okay, let's move on to our final big challenge. Streamlining complexity. In so many large companies, right, the systems for ads, recommendations, like for the homepage, specific items, your cart, even the thank you page after you buy something,
Yeah, they're all over the place.
and search, they're all separate. This often leads to just a proliferation of bespoke models, tons of duplicative engineering pipelines.
High maintenance costs.
Exactly. And a significant lack of knowledge transfer between models. One model learns something useful, but the others don't benefit. It's just a messy accumulation of technical debt over time.
It really is. And this is precisely what unified models are trying to solve. I mean, if this approach works so well for fields like vision and language, unifying diverse data types under one model,
Right, like multimodal models.
yeah, why not recommendation systems? And actually, we've seen this concept bubbling up for a while. Stripe, for example, built a single transformer-based model for payments fraud that unified their understanding of all sorts of different payment sequences.
Interesting. Okay, so a prime example in the recommendation space comes from Netflix with their unicorn model.
Right, the unified contextual ranker.
Their problem was exactly what we just described. Separate teams building separate bespoke models for search, for similar item video recommendations, even for pre-query recommendations.
The stuff suggested before you even type.
Yeah. And this siloed approach just led to high operational costs and tons of missed opportunities to learn across these different contexts.
Makes sense. Duplicated effort, missed synergies.
So their solution was a unified ranker that could process unified input. They very carefully designed a data schema where all these different use cases, user ID, item ID, search query, country, the specific task like search, pre-query, or more like this, could all use the same input structure.
A common language for the model.
Exactly. And a really clever part of their design was how they handled missing information.
Ah, the imputation bit. Yeah, that was neat. For instance, if you're doing an item-to-item recommendation, say after you finish watching a show, you
Hmm.
don't have an explicit search query, right?
Right. There's no query involved there.
So to unify the input, they simply use the title of the current item the show you just watched as a sort of pseudo-query to find similar items.
Oh, okay. So it could still fit the unified input format.
Exactly. It allowed that single model to handle all these really disparate tasks.
And the outcome. How did this unified behemoth perform?
Well, the outcome was that it was able to match or exceed the metrics of their existing specialized models across multiple tasks.
Okay. Match or exceed might not sound like, blowing the doors off
Right. It
initially.
doesn't sound revolutionary on the surface, but it's about so much more than just the raw metrics. It's about eliminating massive amounts of technical debt,
Cleaning house.
simplifying the entire system, building a much better foundation for future iterations. It allows them to iterate and innovate way faster now.
Right. It sets them up for long-term agility, which is huge.
Absolutely.
Then there's Etsy, taking a similar unified approach, but focused more on unified embeddings.
Yeah, tackling their unique challenges.
Etsy, has this constantly changing inventory of unique, often handmade products. Users might search for very specific things like rustic wooden Mother's Day gift, maybe.
Super specific queries.
Right, which might have few direct text matches in product descriptions. Or they might use very broad queries like just gifts. The challenge is that traditional text-based lexical embeddings don't always capture those nuanced user preferences or the item's essence.
Yeah, matching intent is hard there.
So their solution was a unified embedding and retrieval system. Again, following that familiar two-tower model, a product tower and a query encoder.
Seems to be a popular architecture.
It really is. The product encoder uses T5 models, those powerful text-to-text transformers for text embeddings from item descriptions and also from query product interaction logs.
Learning from behavior, too.
And the query encoder handles the search queries. What's smart is that both towers share encoders for things like text tokens, product categories, and even user location.
Ah, so it can match users to nearby sellers or products.
Exactly, which is great for a marketplace like Etsy. And user preferences, like past queries or purchases, are encoded via what they call query user scalar features.
Injecting personalization. And here's a really neat technical detail. Etsy incorporated a quality vector, stuff like product ratings, how new the listing is, conversion rate directly into the product embedding. They just concatenated it.
Slapped it onto the end of the embedding vector.
Pretty much, yeah. And then for the query vector, just to make sure the dimensions matched up for calculating similarity, they simply added a constant vector of the same dimension as the quality vector.
Just a placeholder, basically.
Right, a simple trick for compatibility. And it worked remarkably well.
How well? What were the results?
The results for Etsy were genuinely significant, especially for e-commerce. They saw a 2.6% increase in conversion across the entire site.
Wow, site-wide conversion lift of 2.6% is huge.
It really is. And over a 5% increase in purchases originating from search.
Again, very, very strong results that go straight to the bottom line.
Definitely. Now, it is important to note a potential caveat with these unified models.
Okay, what's the catch?
Well, while they absolutely simplify systems and improvements can transfer across different tasks, which is great, there can sometimes be what's called an alignment tax.
Alignment tax, meaning
Meaning that sometimes improving performance significantly on one task, say search, might inadvertently make another task, maybe homepage recommendations, slightly worse. The model optimizes for an average across tasks, perhaps.
Okay, so optimizing for everything at once might lead to compromises.
Exactly. And in those cases, you might find you actually need to split that single unified model back into maybe 2 or 3 separate, slightly more specialized ones to get the absolute best performance across all your critical use cases. It's a trade-off.
Makes sense. It's not always a one-size-fits-all solution, even with unification.
Right. There's nuance.
Okay, so wrapping things up. If you take away 3 big ideas today that are really shaping the future of how we discover and interact with information online, they are semantic IDs,
Understanding the what.
data augmentation with LLMs,
Getting better data, cheaper and faster.
and unified models.
Streamlining complexity and learning holistically.
Right. These advancements, they aren't just about small incremental improvements anymore, are they?
No, it feels more fundamental.
They're fundamentally changing how companies deliver value to you, the user. They're making recommendations more intelligent because the systems finally understand the content's meaning or are getting much better at it.
Yeah, moving beyond just collaborative filtering.
They're making data more abundant and higher quality at lower cost, which fuels better models. And they're streamlining these vastly complex systems to be more efficient and learn from everything all at once.
It's a convergence of capabilities. So maybe a final thought to leave people with.
Mhm.
Consider the implications here. If AI can now understand the meaning of an item, generate high-quality data to train itself, and unify these vast, complex systems to learn from everything simultaneously, how might that change our relationship with digital products and services,
Yeah.
like in the very near future?
Yeah, what does that unlock?
What new possibilities open up when basically every interaction you have becomes a richer, more meaningful learning opportunity for the system that's serving you? Where does it lead them?